So we've already discussed how to solve linear equations that are in systems, so linear systems of equations. Now what we're going to look at is these nonlinear systems of equations. So a nonlinear system of equations is a system in which one or more equations is nonlinear. So if both of them are nonlinear, or if one of them is nonlinear, okay? So a solution to a nonlinear system of equations in two variables is an ordered pair, remember, ordered pair, with the real valued coordinates that satisfies each equation of the system. So remember, it has to satisfy both of them. And it has to be an ordered pair, an x and a y. So a nonlinear system may have no solution, or one solution, or more solutions. So this is again where we have to be careful with it. We can still use our substitution and addition. Just remember, with substitution, solve the system where one of the equations is linear. So if one of the equations is linear, then we want to use substitution. For example, right here, we have x squared plus y is equal to 6, x minus y is equal to a negative y. So I'm going to solve one of these for either x or y. It doesn't matter which one I solve for. So let's solve this top one for y. So I've got x squared plus y is equal to 6. So I'm going to subtract the x squared from both sides, and I will get that y is equal to a negative x squared plus 6. So now what I'm going to do is I'm going to plug this in for the y of this second equation. So I'm going to have x minus this entire thing, negative x squared plus 6. Be careful, watch this sign, okay? Because it's a negative y, I have to remember to distribute that negative in here. So I've got to distribute this negative into both of them. So I actually end up with x plus x squared minus 6 is equal to a negative 4. Rewrite it in terms where your x squared is first. Now I'm going to add 4 to both sides so that I can get it equal to 0. So x squared plus x minus 2 is equal to 0. Here I can factor, I can use the quadratic formula, it doesn't matter. I'm going to factor two numbers that multiply to give me a negative 2, that add to give me a positive 1. It's going to be a positive 2 and a negative 1. Again, you would find these exact same resulting values if you had used the quadratic formula. So x plus 2 is equal to 0, and x minus 1 is equal to 0. Solve both of these, subtract a 2, so x is equal to a negative 2. Add a 1, x equals 1. So I have two possible values for x. What I have to do is I have to plug both of these back into one of my equations. I'm actually going to use the one where I already have it solved. So I'm going to use y is equal to a negative x squared plus 6. I'm going to start with x equaling negative 2. So y is equal to a negative. We have to be careful about some of this because of that square and the other signs. This square only squares this negative 2. Don't combine these two things. We got to take care of the exponent first. So negative 2 times negative 2 gives me a positive 4. I'm going to bring everything else straight down, including that negative sign. So now I have a negative 4 plus 6. So y is equal to a positive 2. So I have an ordered pair, negative 2 from my x and a positive 2 from my y. That is one solution. I've got to still plug in this x equals 1. So I'm going to have y is equal to a negative, and then I'm going to plug in this 1 squared plus 6. Now 1 squared is 1, so this is a negative 1 plus 6, so negative 1 plus 6 is 5. So I have the ordered pair 1, 5. This particular system of equations actually had 2 different solutions. Let's do one other one where we're going to solve using substitution. Notice I already have this one where y equals something. So I'm going to plug this whole thing into this y. Okay? So I'm going to have 4x squared minus, and then I'm going to plug this entire thing, square root of 1 minus x, and that's going to be squared, equals 4. Well, remember, the square and the square root cancel each other out, but be careful because of this minus sign. I still have this, and the negative sign has to be distributed. So whenever I distribute this negative sign, I get 4x squared minus 1 plus x equals 4. Need to rewrite that in the form ax squared plus bx plus c. I'm going to subtract a 4 from both sides to set it equal to 0. So I get 4x squared plus x minus 5 is equal to 0. Again, you can solve by the quadratic formula. You can factor. Either way, I'm actually going to factor because 4 times negative 5, my a times my c, is a negative 20. Factors of negative 20 that add up to a positive 1 going to be a negative 4 and a positive 5. So I'm going to get 4x squared minus 4x plus 5x minus 5 equals 0. Take out my greatest common factor here, which is a 4x, leaving me with an x minus 1. Take out my greatest common factor here, which is a 5, leaving me with an x minus 1. So I have an x minus 1 times a 4x plus 5 equals 0. And I'm going to erase this right here so that it get it back out of our way. So we have x minus 1 equals 0 and a 4x plus 5 equals 0. So add the 1 to both sides. So I get x is equal to a positive 1. Subtract 5 from both sides. 4x is equal to a negative 5. Divide by 4. We want these to be as precise as possible. So leave this in fraction form. We want the exact values, not rounded or anything of that nature. So I have an x equals 1 and an x equals negative 5/4. I have to plug that back in to my y equals square root of 1 minus x. So let's start with the x equaling 1. Y is equal to the square root of 1 minus 1. Well, 1 minus 1 is 0. Square root of 0 is 0. So I have an ordered pair at x being 1, y being 0. Now plugging in the negative 5/4. So we have y is equal to the square root of 1 minus a negative 5/4. So a negative times a negative actually gives us that positive. So 1 plus 5/4. And you can do this in your calculator and everything, but again, we want fractions at the end. So think about this as 4 over 5, not 5 over 5. So that's 4 over 4 plus a 5 over 4. Well, 4 plus 5 gives me 9/4. And whenever I take the square root of a fraction, remember, it's the same thing as taking the square root of 9 and taking the square root of 4. Well, the square root of 9 is 3, Square root of 4 is 2. So I have 3 halves as my y. So I have a second solution, negative 5/4 for my x, and a 3 halves for my y. So I have 2 solutions. You can plug these back in and check yourself, which is a great idea. So try some of these where we're doing substitution for nonlinear equations.